Good afternoon and welcome to today's presentation, Slip, Trip, Imbalance, and Fall Accidents. The information presented by the expert is not to be used as legal advice and does not indicate a working relationship with the expert. All materials obtained from this presentation are merely for educational purposes and should not be used in a court of law sans the expert's consent, i.e. as a business relationship where she or he is hired from your particular case. In today's webinar, Dr. Berkowitz will discuss cause of slips and falls, definition and effects of friction, aging and falling, floor considerations, fall prevention, and accident investigation. To give you a little background about our presenter, Dr. Carl Berkowitz has held various managerial and administrative positions in the transportation industry, government, private, and academic sectors. He has extensive multi-modal experience in transportation and has written and edited numerous reports, studies, and articles. He is a professional engineer and a member of the American Society of Civil Engineers, as well as a member of many other prestigious associations. He was a distinguished professor of transportation and director, Center for Intermodal Transportation Safety and Security at the Florida Academic University, and Deputy Director at the Florida University Consortium. Attendees who require a passcode, the word for today is slip. During the Q&A session, we ask that you enter this passcode into the Q&A widget for CLE reporting purposes. The Q&A is located to the left of your screen. Please remember that if you're applying for CLE credit, you must log onto the computer as yourself and stay for the full 16 minutes. You are also required to complete the survey at the end of the program. Please note that CLE credit cannot be given to those watching together on a single computer. Tomorrow morning, we will send out an email with the link to the archive recording of the webinar. The slides can be downloaded from the resource list to the left of your screen. Also, due to technical difficulties, only the first portion of the slides are available through the presentation. During the second session, you can download the remaining slides through the resource list. Thank you for attending, and Carl, the presentation is now turned over to you.
Thank you very much, Rochelle, and thank you for your patience, and I'm sorry that you're suffering technical difficulties, but I think we can overcome all those difficulties. And by the way, Rochelle, if anybody wants to ask a question as we're going along, I'm happy to take the questions on the fly. We don't have to wait until we reach the Q&A section.
Sure, that's fine, Carl.
Okay, here we go with the definitions. I think it's important to understand when we talk about slip, trip, imbalance, and fall, what we're talking about. And slip basically is when we deal with the interaction between the feet and the walking surface, and we're concerned about the friction between those two surfaces and the traction. And when we have too little friction or traction, we lose we have a slip, which is the result of losing our balance. A trip is different in that a trip is when we engage with an object or some kind of irregular change in height along the walking surface. And the body, and if you're familiar with Newton's law, a body in motion stays in motion. So the body stays in motion and continues to move, resulting in a loss in balance and a trip. And the end result of the slip trip is a fall. And the other possibility is an imbalance, and that's when you step on an unstable surface, such as a loose tile, and this can result in also a loss in balance. And these incidents are of slippery surfaces or uneven surfaces or any other kind of obstacles is what we call the slip, trip, and fall scenario. And the effects of this slip, trip, misstep, and fall is generally nothing happens, or serious injuries and serious financial consequences can be expected. And think about it, every day each of us takes thousands of steps, and it only takes one single step to have a slip, trip, misstep, or a fall. Let's look at some of the statistics. This is basically an area that attorneys should be most concerned about because second only to automobile accidents, slip, trip, and falls is the second largest number of accidents that occur to people in the United States. Tens of thousands of pedestrians and passengers on public transportation suffer injury from slip, trip, imbalances, and falls every day. And the cost of this is in the billions and billions of dollars. For example, emergency room visits per year as a result of slip, trips, and falls has been estimated to be about 8.9 million. 15% of the accidental deaths are the result of slip, trips, and falls. And 17% of all disabling occupational injuries are the result of slip, trip, and fall. If we look at it from a workplace point of view, slip, trips, and falls result in 1 in 6 lost time as a result of injuries, 95 million workdays per year lost, and an average per injury 11 days away from work. And when you add up these costs, they're quite significant. And the cost of injuries far in any calculation exceeds the cost of preventing these injuries in the first place. So let's look at the slip, trip, and fall factors. They generally have to do with the floor, the condition of the floor, the type of footwear that's being worn by the individual. We also have many cases that are invented based on fraud. We also have issues such as pre-identifying hazards, and most importantly, training plays an important role as well. If everybody in the system is properly trained, a lot of these slip-fall incidents could be avoided. And the main causes, if we look at it from a global perspective, human factors is really the number one issue. And then of course, we have the wet and slippery surfaces and issues involving taking care of the environment. That's the housekeeping issues. So let's look at the accident factors as they appear. We have the person involved. They're doing some kind of activity. There's an environmental issue, and it could be involving temperature, light, weather, poor maintenance conditions to the working surface, which ultimately results in that accident. The prevention of most slip, trip, and fall accidents is at the first level, and that is remove the hazard condition in the first place. This is the simple way, the easiest way, and the most proof positive way. It's always been said that, if a person is careful and they watch where they're going, the slip, trip, and fall accident would occur. But let's think about how much time does an individual have when they are confronted with a slip, trip, or fall situation. Generally, it's an instantaneous situation. In order for a person to be able to react to potential for a slip, a trip, or a fall, there's what we call the perception reaction time. The time it takes to recognize the situation, to understand the situation, to decide what action to take, and then to take the necessary action. These 4 steps are what we call the perception reaction time. And in most cases, when we analyze the slip, trip, and fall, the slip experience and the fall experience, it usually takes place in less than a second. So a person has to perceive, react to avoid that slip, trip, and fall in less than a second. Now, if you think about how fast a person is walking, a person generally walks about 4 feet per second. So if this accident occurs within 1 or 2 feet, we're talking about a time span of a half a second. Now, in the laboratories, tests have been conducted on how long it takes to perceive something and react to it. And generally speaking, the best that they've been able to accomplish in the laboratory is 1 second. More likely, the time it takes to perceive and react to a situation is probably 1.5 seconds to 2.5 seconds. Far greater time than the time in which there's slip or the trip and the fall takes place. Falls are too commonplace, and they occur in every age bracket, from infant to an older person. And generally, we get up, we slip, we trip, we fall, we get up, and we're a little bit embarrassed, and we then proceed moving forward. But when an injury does occur, it can be debilitating and it could be far-reaching. The National Safety Council, as I mentioned earlier, that's second only to automobile injuries. And we have to take the potential for slip, trips, and the ultimate fall, or the fall without the slip and trip, very seriously, because the results can have permanent disability effects on the individual involved. Falls can occur on level surfaces, on slopes, on steps, on stairs, from heights, and many different causes. And what happens is, in the slip, trip, and fall, a person loses their balance because of some reason, whatever that environmental reason is, or the construction design reason, and the person falls to the ground or to another level, which could be falling from a high place to a low place. We categorize falls into main category. We have the area that we deal with is called circumstances. Is it level? Is it slope? Is it steps? Is it stairs? It's from heights. The age of the person. Is it a healthy adult, a child, an older person, an unhealthy person? Is the place a hotel, a terminal, a parking area, a private residence? These are the primary fall categories. The factors in falling are the change in our gait because of a slippery surface or striking an object that's above the surface, where we lose our balance, how tall we are, how strong we are, how good our vision is, and what we are doing at the time of the incident, our behavior. And normally in walking, walking is the process by which we step from balance to imbalance to balance. So when we have both feet planted on the ground, we're in balance. When we pick up one foot to move forward, we're in imbalance. And then when we put that foot down, we're back in balance again, and this process continues. As we walk, we're from balance to imbalance to balance to imbalance. And the same goes for our gait. In terms of gait, we may be walking quickly, and we may be taking longer steps and longer strides. And again, we go from being supported when both feet are on the ground to being unsupported when one foot is off the ground. And if we look at dynamics of a slip and fall, we tend to slip and fall backwards, or hit a surface and also fall backwards. In terms of falls, we could, where there is no slip, trip, and there's a change in elevation, like the edge of a balcony or something like that that hasn't got proper railing, that fall may not involve a slip and a trip. Falls are also influenced by the person's health. Are they fatigued? Are they under some particular type of medication? Are they under the influence of alcohol? Are there particular environmental issues, such as water, rain, contaminants, other debris, and the activity that they're participating in at the time of the incident? When we fall from a level point to another level point in the same level, generally those type of injuries are limb fractures, sprains, back or head injuries. When we have fall from heights, we're talking about injuries that could be far greater and more serious. And the severity depends upon the height of the fall and the kind of contact surface that you fall on. I remember when I was in high school and college in gym, we had to climb a rope, and if you fell from the rope, you fell to a padded surface which absorbed the force of the fall from the rope. If you don't have a padded surface when you fall, then you're hitting a rigid surface, and your body, there is nothing to absorb the shock of the fall, and that's why we have this serious injury from falls. If we're thinking of public transportation, There are various factors that come into play in terms of this slip, trip, and fall. First of all, let's look at the personal factors. This is the person's vision. Do they have any impairments? Do they have fear of falling? Do they have medical balance issues? What are the environmental issues? Is there low lighting, obstacles, or steps that are not in accordance with the codes and the standards? Is there a specific activity, like difficulty for the individual to make full use of the public transportation and having difficulty accessing the transportation? The risks that we have in public transportation, for example, are the steps. The codes call for all rises on steps, that's the height of the steps, to be equal or very close to equal, and to have standard treads on the steps as well. Unfortunately, this is not always the case in terms of public transportation, where you might have a lack of handrails or arm mark edges or different heights in the steps. Another cause of transportation accidents for pedestrians is when the vehicle makes a sudden, unexpected, and violent stop or lurch, and this causes the individual to lose balance and to fall. And basically, the reason for this goes again back to Newton's law. Newton's law says that a body in motion stays in motion. So even though the vehicle may have stopped, the person, unless they are restrained in some way, will continue in moving in the direction that the vehicle is moving prior to the sudden stop. Of course, slippery surfaces where you have reduced traction between the shoe and the surface, there's the potential again for loss of balance. When you're on a crowded vehicle, there may not be enough seats for everybody, or there may be a lack of grab rails or straps for individuals to hold on to support, so they are secured when the vehicle is in motion. Also, we've got to be concerned about items being left in the aisles of the vehicles and people tripping over them, and the lighting when people are moving through the vehicle. This all creates various risks and can result in a fall on the part of the traveling public. Let's take a quick look at falls from heights. This is when we have an edge which is unguarded and not protected, and you go from a higher surface to a lower surface, and the height of the guard may be too low that people lean over to look at something and lose their center of gravity and fall over the rail. And falls from heights, of course, are responsible for most serious injuries and can result, in many cases, in result in death. And in terms of the workplace, there have to be certain provisions made when you have a potential for fall that is greater than 4 feet. They have various restraining methods and nets and other procedures that need to be followed. Everybody asks me, where there's the first provisions for protecting individuals from fall. And interestingly enough, if we look in the Bible, the original traditional Bible, and we look at Deuteronomy 22:8, we find that the Bible already is warning us about the dangers of falling from a high place to a lower place. There are numerous standards and codes out there for slip, trip, and fall. These are some of the standard organizations that have promulgated rules and regulations and guidance for providing safety against slip, trip, and falls. In addition to this, there are various building codes that have been promulgated taking advantage of these standards and codes and having them directly incorporated into the building codes to protect individuals from those kinds of hazards. There are a number of engineering principles that we take into consideration, and of course, the first and most important is to understand the hazard. And once we understand the hazard, we should design and deal with the hazard by eliminating it. The best way to avoid the danger of slip, trip, and fall hazards is eliminating it. If it's impossible to eliminate it, The second stage is to warn of the hazard. And if we're unable to, and then in addition to warning, we need to minimize the risk of the hazard by posting placards in the area, ensuring that people avoid that area, in addition to providing warning signs. This is very important. The third stage is one we hope to not have to deal with. Hopefully, the hazards can be dealt with by elimination or by providing proper warning. And there are various codes, and we're going to talk about them later on. There's what we call the ANSI code Z535, which is the code that helps us in designing the proper warning devices, warning signs to protect individuals from hazard. The most important and the most dominating factor when we're dealing with slips is the coefficient of friction. That's the friction between the footwear and the floor material. And also, secondly, is the geometry of the walkway, its slope, its angle, the continuity, if it's steps, and the environmental conditions. Is it outdoors, indoors? Is it swept clean? Are there contaminants? Things of that nature. Let's look at the elements of a slip and a fall. The individual approaches the slip area. The slip area is not visible to the individual. The individual steps on the slippery area. The individual experiences a slippery surface. The individual recognizes the slippery surface. The individual perceives the danger of losing balance. The individual tries to regain balance, and the attempt is made to try to recover. The individual is unable to recover, loses balance. The individual slips and ultimately falls. And this whole process takes less than a second. And as I mentioned earlier, the perception and reaction time is probably greater than a second. So therefore, unless a person is given adequate warning and preparation, there is no way they can avoid a slip, trip, and a fall. The definition of friction is the interaction between two surfaces, one moving relative to the other while maintaining contact. The first machines that were developed to determine the coefficient of friction went back to the time of Leonardo da Vinci. He developed the first friction machine. Coming more towards the modern area, Charles Augustin de Colombo studied dry friction, and he sort of laid the groundwork for how we look at and study friction today. And just if we look at friction, think about something that's at point A, and it's going to move to point B. If it's on wheels, we know how easily it moves. If it's one surface on another, we know how hard it is to move the one surface against the other, and that's because of the friction between the two surfaces. In the machinery industry and various industries, we lubricate between the two surfaces of friction in the automobiles, and that lubrication is grease or oil, and that tries to reduce the friction to zero. In the environment, we also have circumstances where friction approaches zero, and that's when we have ice. Ice comes pretty close to the coefficient of friction of zero. This is the formula for the coefficient of friction. I'm not going to get into too much detail, but one could easily calculate it. There are machines out there that do the calculations, and I'll talk about that in a moment. We also can calculate the coefficient of friction on a slope, and this is the calculation of a coefficient of friction on a slope. Of course, with a slope, we have gravity helping us a little to overcome the coefficient of friction. And of course, on ramps, we have a similar circumstance. And in addition, there are many standards on the slopes of ramps and how ramps should be designed. so that people don't fall because of the steepness of the ramps. And of course, ramps also required to have handrails to prevent people from where the ramps may be a little too steep or not too steep at all, where people have disabilities, to help people to negotiate those ramps. One of the major concerns in why people slip on surfaces is we have a walking surface which has a high level of high coefficient of friction, and then suddenly and unexpectedly we step into an area with a low level of coefficient of friction. And this instant change between the two conditions is what can result in a slip. If a person is warned that there is an area they're going to be moving into, then they can prepare for and adjust for that change in the coefficient of friction. This is just some examples. You have a concrete that absorbs the moisture, and then you have a concrete that's painted that doesn't absorb moisture. And here we have two wet surfaces, but with two different coefficients of friction. Of course, when you have contaminants, that reduces the coefficient of friction and changes the mechanism of our walking, and that's why we end up hitting these surfaces, sliding and falling. These are some examples of coefficients of friction for different kinds of materials, and you can see, that dry materials even steel have a higher coefficient of friction than wet or oily or contaminated materials. The research that's been done up to this date recommends that any surface where individuals are walking should have a coefficient of 0.5 or greater. In fact, the ADA specifies actually a minimum value of 0.6 for the coefficient of friction on accessible pathways. There are various organizations you can go to obtain coefficients of friction, but they're generally 0.5 or greater, and these are those organizations: OSHA and the American Disabilities Act Accessibility Guidelines, the American Society of Testing Materials, the National Fire Protection Association, and the state and local building codes, which are basically adopting the coefficients of friction from those other standards. And they usually are footnoted into the state and local building codes where they took that standard from. Let's look at friction and traction, and you can see that the greater the coefficient of friction, the greater the traction. And without traction, we have the slippery condition. And you can see the different categories of slippery conditions, from a very slippery surface like ice to a very good surface, which would be like a roughened concrete. Rochelle, I think we have all the slides now uploaded.
Yes, we do.
So we can just continue along. Thank you. The attributes of safe walking are, does the various aspects of the walking surface meet the accessibility requirements? Do they provide warning where warning is necessary? Is the walking surface have clarity? Do people understand it? Is it clear? Is everything on the walking surface conspicuous? Is it designed to national standards of care? If there's an issue, is there detectable warning provided? Even when there is no issue, when there is a change in situations between a sidewalk and a roadway, we have these curb cuts with tactile tile to identify for people with visibility issues and other issues that they're going from one transition surface to another. This is also used on the edges of platforms and other areas. If you ride the subways or the railroad, you'll see at the edge of the platform they have these dimpled tactile tiles to warn people that they're approaching an edge. The important thing in safe walking is that everything that happens has to be based upon our experience. We should not have unexpected events. Everything that happens should be expected. And only can we be safe if everything we do is with expectancy. And information should always be provided in multiple formats so that people with disabilities can discern the information, such as vibrotechnical or braille or announcements or things of that nature. And also, we need to have not only detectable warning and active warning, but also passive warning. Passive warning is very important. We got to tell people. I remember in military training, was done in 3 parts. You're going to tell people what you're going to tell them. You tell them, and then you tell them again, because people tend to forget. And you got to keep reminding people, especially when there's an issue in the walking surface that needs to be addressed by the walking public. The surface should always be visible and smooth, and also there should be proper lighting and other requirements, not only for making the walkway safe, but to give people confidence in off hours and in the evenings that there's, that they can feel secure while walking through a particular area. Studies have been done, and the British Standard Institute conducted a study to determine under what is the effect of different coefficients and the probability that there will be a slip risk. And this table shows you the different coefficients of friction for different activities, that's walking straight or making a turn, and the probability of a slip occurring based upon the coefficient of friction. Here are some other additional coefficients of friction based upon a dry surface and a wet surface, and you can see the significant differences between a dry and a wet surface for such areas like tile, carpet, asphalt, vinyl tile, concrete, terrazzo, rubber. You can see how dramatically the coefficient of friction is reduced if it's wet. Could you imagine if instead of it just being wet, that somebody spilled oil or grease or some other kind of lubricant on the surface, and what would happen to the coefficient of friction? Now, there are other studies that have been done, and this is one that is used to predict the possibility of a slip and a fall as a result of the dynamic coefficient of friction. And I'm not going to go into too much detail, but if you know the coefficient of friction, you can determine the probability of an incident occurring. Rochelle, I guess we could take questions if anybody has any questions.
Yes. If all the attendees can enter the passcode for today. And also, Carl, I sent a question to the team chat, so you can just, if you receive that, you can ask
I don't see anything in the chat. I don't see anything.
Okay, so I'll just ask it. Is an expert necessary to opine that a wet floor presents an unreasonable risk of harm? What standard and case law supports 1, an affirmative answer, and 2, a negative answer?
Well, one of the difficulties with when there's a wet floor or something of that nature, and you come back after the time of the accident, we don't know if the conditions are the same. And the various machines that are used to measure the coefficient of friction are not always that highly reliable. It's a difficult situation. There needs to be empirical evidence that the surface was wet at the time of the incident, and then try to somehow replicate the situation, determine the coefficient of friction. Because just because the surface is wet doesn't necessarily mean that it's an unsafe condition. It depends on the surface. A surface without being wet could be more dangerous than a surface that is wet. Certain materials are more dangerous that even if they're not wet. And what are required to make those surfaces safe is that they need to be treated with special chemicals which increase the coefficient of friction. Slip, trips, and falls are kind of tricky, especially the slip component when there's a wet surface, and then you have to somehow prove that the surface is wet and that the coefficient of friction was such that the surface was slippery and caused the fall. Did I answer the question, I hope?
Yes. Next question, are there any special considerations a hospital should make for patients who are not determined to be fall risk? Is being on pain medication sufficient to a patient a fall risk, to make the patient a fall risk?
I'm sorry, I didn't catch the question.
Are there any specific considerations a hospital should make for patients who are not determined to be fall risk? Is being on pain medication sufficient to make a patient a fall risk?
Well, I would say that certain medications, if you read the printouts, anytime a medication is prescribed, maybe not so much in a hospital, but if you get a prescription and you fill it, there will be instructions as to what could be the ill effects of that prescription, which can result in a fall. There are many types of medicines out there that can create, I'm not a pharmacist, but there are many medicines out there that can create an imbalance on the part of the individual, and the individual taking that medicine should be ambulatory. It should not be allowed to walk while taking that medicine. And the hospital should certainly know those limitations based upon the medicine that's prescribed.
Next question, please discuss the issues pertaining to black ice.
Well, that's an interesting question. Black ice is a situation where usually it always occurs on asphalt, and when the moisture on the asphalt freezes, it's sometimes very hard to detect that there's ice present on the roadway. The black ice should be the highway departments should become aware of these situations where water collects on these asphalt pavements and should make every effort possible to treat the situation with some kind of brine or other melting chemical to ensure that there isn't black ice. Small segments of black ice can be dangerous to pedestrians. Large sections of black ice can be extremely dangerous to motorists if they apply the brakes on the black ice, because now the coefficient of friction between the tires and the pavement is quite significantly reduced. As I mentioned before, ice has a coefficient of friction close to zero, and sometimes cars that brake on ice experience a situation that is very similar to when one brakes on water, and that's hydroplaning, where the tires can leave the ground and the car can go into a situation which we call hydroplaning, where it's sort of not on the ground and it's slightly in the air, and the distance to stop has been expanded significantly. Tricky situation, black ice.
Next question. Can you address the relationship between a very strong wind and a slippery condition? Is there a method of calculating how much the wind will increase the risk of fall of a slippery surface?
Any environmental situation such as wind, if we know the speed of the wind and the direction of the wind, one can calculate the force created by the wind. But this is kind of very difficult to get that kind of information. Wind changes direction constantly, and the speed of the wind changes constantly. But wind can cause somebody that's on a slippery surface to fall.
What does buffering do to vinyl flooring?
Pardon me?
What does buffing do to vinyl flooring?
Buckling?
Buffering, yes.
Buffering
vinyl
or
flooring.
Buckling? You mean buffing the vinyl flooring?
Yes.
I'm not quite. Vinyl flooring, some of the vinyl flooring could be very slippery, and they need to be treated with special chemicals to increase the coefficient of friction. Buffing could remove those materials, and if the particular flooring is slippery, it will return to its slippery condition because the buffing buffing will remove that chemical which was used to increase the coefficient of friction.
How does placing sand on sidewalks during thawing and refreezing decrease the chances of falls?
Well, anything you do to increase the coefficient of friction, sand has a higher coefficient of friction than ice, and generally speaking, the sand may not be the best treatment for ice, but it's better than ice melting is probably the best treatment, and sand would probably be a second treatment. But there's a problem in certain sidewalks, the way they're manufactured. Some of these chemicals that are used to melt ice cause damage to the sidewalks, so one has to be careful about that. But anything that can increase the coefficient of friction between the footwear and the walking surface decreases the possibility of a slip.
Thanks, Carl. You can continue with the presentation.
You're welcome. There are various trip prevention standards, and these standards basically focus on a change in elevation in the walking path of a quarter of an inch. If it's a quarter of an inch, that's within standard. If it's greater than a quarter of an inch, the standards call for the surface to be sloped. And this is very important. The reason for this is when a person walks, they don't lift their feet very high. They lift it slightly more than a quarter of an inch. So if you have a surface that's height between two surfaces, excuse me, which are greater than a quarter of an inch, there's a very strong likelihood that that could be a tripping hazard. And this is the standards. And what the American, everybody says, well, my client is not an ADA individual. The American Disabilities Act only adopted the standards that were developed for everybody. The American National Standards Institute and the American Society of Testing Materials, the ADA just adopted those standards. And those standards are for everybody, and not just for those who are ADA. And this is just a further detailing of the ADA guideline and the change in grade from 1/4, what you do when it's greater than 1/4 of an inch. John FRUIN is considered the father of pedestrian safety, and his advice is that walks should be continuous common surface, and there should be no interruptions by steps or abrupt changes in level. I was recently in Singapore, and in Singapore, the sidewalks have steps in them. And the first time I encountered that, I almost took a slip, trip, and fall, actually a trip and fall. But once you become aware of the situation, and they don't make you aware, but that's an anomaly of Singapore, where you find steps in the sidewalks and steps entering a store that's off a sidewalk as well. Canadians also offer guidance, which is similar to our OSHA, about the importance of good housekeeping and how to avoid trips and falls. The Institute of Transportation Engineers stresses that changes of level should be avoided whenever possible, and this is the way to best to avoid a tripping hazard. Aging and falling is becoming very important and is the most significant area in terms of slip, trips, and falls. As people get older, they are more subject to these kinds of situations. And this is just a breakdown of where these type of accidents occur amongst the aging. And you can see that the private house is the primary area, but transportation and institutions and commercial areas also are areas where this occurs. And aging brings along sensory impairments and other illnesses and muscular weaknesses and diminishing conditioning. The AARP stresses the importance of exercising at least 3 times a week, at least 3 hours a week, and the importance of that is for an individual to maintain their health and to avoid these situations of slip, trips, and falls. This is a chart that was developed by the World Health Organization, and you can see how as people get older, their abilities and their strength decreases, opening them up just like an infant to more possibilities of slip, trips, and falls. And unlike an infant, our human body is not as flexible as infants, so when an elderly person slip, trips, and falls, it can be catastrophic. The types of injuries that occur are, and this is the breakdown, the greater number of injuries are to the head and the face, and you can see to the legs and to the arms, and then you can see that the head and face and the trunk of the body is pretty much equal, but the primary injury areas to the legs, and of those injuries, 17% are to hips, and most of these kinds of hip injuries require the elderly person to undergo hip surgery and get a hip replacement. It's not a pleasant situation. These are this is based upon data that was collected at a particular hospital of 1,600 injured individuals, and this was the breakdown of the injuries to those individuals. You can see from this chart how our population is rapidly growing older, and this consequently will result in more and more elderly people being subject to slip, trips, and falls, and we have to take that into consideration. The system has to become more accessible and safer for the elderly, all environments where the elderly live, work, and travel. In terms of percentage of the labor force, people working longer years, and you can see from this chart that a lot of people are working beyond 64 into 65, and a lot of people are even working beyond 75 as well. When we're dealing with the surface, these are some of the considerations that must be taken into consideration when considering the surface that an individual is walking on. Workplace injuries are very important to be concerned about. There are numerous standards. OSHA and ANSI have standards as to how to make the workplace a safe place, and the kinds of standards that are applied to the workplace really apply to any place, whether it's the workplace or non-workplace, because people who are working may go into an area that's not exactly part of the workplace, and those provisions need to be carried forward to every place that everybody works in. And we should really have the national standard of care should be the national standard of care that considers all classes of people, not just one class of people. The parking lots have their own individual issues. I'm not going to get into too much detail since we're running short on time. You can take a look at these. But these are the general issues that people get injured in parking lots as a result of accumulations of water and the locations of various types of speed bumps and the locations of the blocks that stop cars from going beyond a particular point. Terminal facilities, there are a lot of points where persons can be injured, and it depends on where the passengers are moving through, and changes of elevation, how the stairs are designed, or the handrails, the slopes of the ramps, where the exits are, what type of floor systems are used, the escalator operations, the elevators, moving walkways. There are a lot of potentials for injuries in transportation terminals, and this is just 12 some of the prominent ones. Truck loading docks also offer areas of potential injuries where the dock is level to the vehicle, the housekeeping, the bays, how they're designed, or the trucks chocked so that they don't move when they are being loaded. Bathrooms also have their own issues of safety and slippery conditions, and these are some of the situations that occur and the types of situations that should be taken into consideration. Unfortunately, builders only design bathrooms as safe as possible for those where it's a 55-year-old older community, but these kinds of improvements should be for all classes of individuals, not just for those who are covered by the American Disabilities Act. Ice and snow, as I mentioned earlier, offer a very low coefficient of friction, and unless person knows that there is ice present and they can prepare for it, it offers an opportunity for a slip. And snow, many people have walked on snow, and to only realize that under the snow, which was very shallow in depth, there was a sheet of ice, and on the sheet of ice, they end up slipping. A famous accident that related to this was the famous guy, Dr. Doc Atkins, who was walking on snow on a day where ice formed on the sidewalk and snow covered the ice. He stepped on the ice, slipped, and hit the back of his head, and the bone, I forget the name of the bone in the back of his head, was pushed into the brain, and he ultimately died. Elevators, escalators, there are various standards that need to be followed to avoid injuries such as the linking between two surfaces should be no greater than 0.25 inches, a quarter inch. There should always be leveling between different surfaces. There also should be controls that the elevator, escalator, or the moving walkway should not stop suddenly. And if they do stop, they should stop slowly so that the Newton's law, which we discussed earlier, that a body in motion stays in motion, that situation doesn't impact the passenger on those particular situations. In terms of sidewalks, these are the kinds of things that will cause slip, trips, and falls on sidewalks. I'm not going to get into too much detail. I'm sure you're all familiar with all these different types of possibilities. In terms of playgrounds, it's amazing. Playgrounds, a lot of the playground areas are designed for children, and you can't believe how the designs don't take into considerations the safety of the children, and the children are open up to unprotected situations. I had a case in Hawaii where in the playground area they had a wall, an unprotected wall, and the children lined up to participate in activities in this recreation area on the wall. And as you would guess, one child turned around and flipped off a wall and was seriously injured. Excuse me. These are some things that can be done to avoid a fall on different types of walking surfaces. And I'm not going to get into too much detail because of the limited time, and we still have 25 slides to yet go through in 7 minutes. Housekeeping is very important. That's the first line of defense in ensuring that we remove slippery and tripping hazards. This is a simple solution. Just clean the area and maintain the area in a clean and safe condition. Where we're unable to eliminate the hazard, then we must provide sufficient warning through signs and symbols to let people know in advance so that they can prepare themselves to deal with the hazard. The name of the game in safety is risk reduction, and there are many ways we can reduce the risk, and this is many examples of what can be done. And I find a lot of the situations where people are involved in slip, trips, and falls, when we get into the nitty-gritty, it's a human factor situation and generally can be attributed back to somebody who is responsible for maintaining the location, failing to be trained properly to take care of that situation. And what we're doing basically when the people responsibility for maintaining and caring and the housekeeping for a situation doesn't take care of the situation, we're now putting all the responsibility on an individual who's traveling through that situation, and for them to have to be in charge of the situation and being able to make decisions and not having the appropriate information to make the proper decision, and the end result is, unfortunately, is the slip, trip, and the ultimate fall. And you know, depending on whose premises it is, there are different kinds of duties that are the premise owner or leasee or person managing that premises is responsible for. They have various duties. They even have duties to trespassers. Just because a person is a trespasser doesn't absolve. In some cases it does absolve, but in many cases the trespasser is entitled to the same protections as an invited guest. There are various statutes out there and notices and proximate causes and damages and all other kinds of situations, which I'm sure the attorneys that are listening to this presentation are well aware. In order to do any kind of evaluation or to determine who's at fault when there is a slip, trip, or fall safety issue, these are kinds of information that are needed, and we want to know if these kinds of things have been followed as the standards been followed, as the standards of care, national standard of care have been met, and are all the standards that are applicable been met, and if it's in a highway or transportation situation, road transportation situation, has the manual of uniform traffic control devices been satisfied, and that's especially in cases involving workplace safety, work zone safety, that kind of situation. If we can't see it, then we can't respond. And even if a person has good vision, if the situation is not conspicuous to them, they're not going to see the situation. You have to be able to see something to be able to react to it. And you also, as I mentioned with the perception reaction time, you have to have enough time to respond. And these kinds of incidents happen in such a short period of time that even sometimes with last second visualization of the situation is not enough time to respond properly. And of course, maintenance is important. Let's always make sure that housekeeping, many accidents occur because of people who are responsible for cleaning say, oh, well, I was there the last 5 days and there was no problem, so I'm sure there's no problem today. Every day, every minute, there's things happen, and areas that are actively traveled by pedestrians and passengers needs to be checked on a regular basis, and more than just once a day. And based upon the type of traffic and the weather conditions, the time interval of inspection needs to be appropriate to the situation. If we were conducting an accident investigation, these would be the kinds of steps that we would follow to determine what the circumstances are that surround the issue of the slip, trip, and fall. And conducting the investigation, these are the things we are looking into and we want to collect information on. In conducting the investigation, we want to make sure that we approach the investigation using the scientific method, because if the case ends up in court, it may be subject to FRUIN or Dalbert standards, and if the consultant and the investigator uses the scientific method, they are protecting, they are proofing themselves from FRUIN and Dalbert. Again, there are various statutory controls that take place in terms of the workplace, in the work system, in the environment, in the footwear. We have various standards that apply to all these aspects, and these can be found in ANSI and ASTM and the ADA and the building codes, etc. And in terms of the theory of liability, we have the failure to comply with the code, the failure to correct, and the failure to warn, and the failure to inspect and maintain. Simple, but And if you're in the position of having to defend a situation, these are the kinds of things you want to take into consideration. This is the type of useful information to build a case for the defense or for the plaintiff. It's important to take into consideration the abilities of the expert to communicate, to understand and interpret information, experience, and as the expert had similar experiences and background in the type of situation that is under consideration. These are things you want to look for: education background, employment history, litigation experience, appearance and mannerisms, and their availability to meet the schedules such as inspections and trials and depositions, etc. And don't forget to get the expert involved early. A lot of times the engineer is brought in at a later date, and there's a lot of information that could have been useful to strengthening the case is lost because the time for disclosure has passed, and the expert could have been helpful in helping identify issues involving the case and helping to make the case stronger, whether it's for the plaintiff or for the defense. And let's bear in mind, we have a duty of care, and we have a duty to warn, whether it's a passenger or a pedestrian. We have a duty to proper train people that are responsible for the safety of individuals. We need to have a periodic inspection program which is suitable to the amount of traffic and activity and the environment that we're dealing with. And we always need to check out on our design standards and bring them up to date, and always provide effective communications to everybody that's in the system, those working in the system and those using the system. Thank you, everyone, and I turn it back to you, Rochelle.
Yes, thank you so much. If all of the attendees can enter the passcode for today, due to the overwhelming amount of questions and the lack of time, we're only going to be able to ask one question. Carl, is it okay for me to send over the remaining questions for you to contact the attorneys or attendees that asked those?
Well, if they would like, however you would like to arrange it, I would be happy to respond to all the questions. If you want to have them come directly to me or through you, either way would be just fine.
Okay, thank you.
I'm happy to answer any questions that anyone has. I know this is a lot of material to squeeze in a short period of time.
Thank you so much for it. Our question is, what is your opinion of coefficient of friction testing? Seems like some experts believe in it and some do not.
I'm on the don't believe in it. The problem is the machines are not 100% reliable. Probably more reliable is the experiment that we did in high school using a weight on a surface and using a spring and a pulley. The American Standards Materials, I'm on the committee, I forget the number, I think it's F13. We've approved 2 types of machines. The problem is, if you don't do the test immediately upon the accident occurring, even immediately may not be satisfactory. You need to know the exact space and the exact environmental conditions in order to obtain a proper coefficient of friction. I don't find that the coefficient of friction measurements are as reliable as we would like them to be, but most attorneys, when they have slip and falls, especially in a building, they would like to have the coefficient of friction measured. The machines can cost anywhere from $400 to $5,000, and their level of reliability, if you're taking the measurements sometime after the accident, is questionable.
Thank you so much. In addition to being your best source for testifying and consulting experts for the past 60 years, TASA also offers e-discovery and forensic solutions, free interactive webinars, and day-in-the-life videos. We also offer research reports on expert witnesses, including the Challenge History Report 2.0, Preliminary Screening Report, and Expert Profile 360. I want to take this opportunity to thank everyone for attending, and most especially Carl Berkowitz for his time and effort in creating this presentation. If you would like to speak with Carl, if you would like to speak with a TASA representative regarding an expert witness for a case that you are working on, please contact TASA at 1-800-523-2319. One of my colleagues will be following up with you regarding the feedback on today's presentation. Thank you for attending. This concludes our webinar for today.